same app at the same time. And if we have luck today, Cornell's in Romania, so we may have some network issues here. But if we're lucky, we're going to see some real-time stuff where we sign it, create a document, send it to Cornell. He can sign it, we can sign it, and then we can record it on the blockchain. So the blockchain, the one and only. This one is actually Ethereum that we're using. Unfortunately, sorry about the screen sharing thing. It's blocking some of the buttons. It also looks like the mouse doesn't work. Yay. Live demos.
There it is.
Where is it going? Something's frozen. There it is. Okay. Oh, wanted over here. Okay. So let's switch windows. So I'm going to create a new document. I could create a couple of kinds of documents. This UI is generated from schemas. So you could have a schema for some kind of data that you want to collect, and it will generate a form that people can then fill out, and that can be signed. And you can also attach files to it. So let's do a vehicle sale. So I want to buy a car from Cornell. I would like to buy. Let's see. How about a van? Let's buy a van so we can live in a van down by the river. That'll be great. And I'll add Cornell as a recipient to this. This is not actually using email, but we're using email addresses as a quick and dirty identifier. And I'm going to add a file to this. Let's pretend that this PDF file here is actually a contract. We should be able to open this up. It will send the actual file to Cornell as well. I'll add a few things in here. I think today is Halloween. So in a perfect world, we'd be using things like DIDs, like Drummond talked about this morning. And that would kind of happen automatically. Let's say this is a Mercedes, and it's a Sprinter. Those are really nice vans. Yeah. Let's get right to the signature. Sorry for this. We may have some validation in here. So I have to fill out the form. And let's give it a price, make it a cheap van. I'll save this, and now I can send it to Cornell. Cornell, if you can hear me, let me show your screen. 1 second. Okay, so you can see that Cornell already has this document. Now, Cornell, can you open it up? So you can see the form data there, and he also has the PDF file. And I don't think this will show in the screen sharing. It'll be in a different window. But Cornell, can you sign the document now? So Cornell signed this, and you can see that I also have. Oops.
Another minute.
Okay. Try to be really quick. I have this document now with Cornell's signature on it, just like that, and I'm going to sign it. So, oops. It went into my signed bucket.
So that was the actual signature. That's what a digital signature looks like. Is that string of numbers? That's what was created from the private key.
So you can see here we have two signatures and two. Unfortunately, these aren't displayed very well. It's kind of mushy to see what it is. But this larger value is actually a certificate of the public key so we can verify ownership of this. And for this demo, the idea was that a credit union would be certificating a end user's public key so that you would know it was actually their key. So we're verifying key ownership. And then we've also got, I want to show you, we have a Merkle root. We made a hash tree out of the attached documents and included that here. So those documents are included in the signature along with this metadata. And
so we do 30 more seconds?
And now
okay,
we'll finalize this. And yep. Okay. So UI is a little sketchy. We need to.
It was rapid.
So yeah, very rapid. We did this in a couple weeks in spare time. And so now you can see there's an Ethereum transaction receipt. So this transaction has been recorded, or this contract has been recorded as part of a transaction. This is actually one valid use of hashing something and putting it on the chain. We wanted to do dual integration, Monax style, and didn't have time to get to it. But ideally, we would have a transaction hash for a smart contract recorded in the document, and then we have the final document recorded here. So that's it.
So thank you. Pretty good hack, huh? I think. So nice work. Everyone clap for Christian and his team, the whole team. So people got interested. So just one thing I'll say about this hack very quickly as a takeaway is grab our code, take our code, use it if you want, report back, ideally with pull request to GitHub. It's you can ask us, or it's at the MIT Media Lab organization in Trust Core ID. And then I just want to say what we want to do next that we didn't really finish is do a mock trial with a bill of sale for the car. Something went wrong. Sally didn't pay the money. Bill didn't give the car. Alice and Bob. So now we're entering into evidence along the lines we talked about. Laying that foundation, see how many steps we can skip from the contract and the signatures and attributions. That's what we want to test. We want to quantify that and then tune the requirements of the technology accordingly to the legal requirements. Thank you, and get out. Thanks, man. I apologize, we're a bit behind. We got. Ian, just